You don't need Python for AI anymore. That's the claim circulating right now in the developer community. Building a modern AI startup involves a complex stack: global chat APIs, retrieval-augmented generation pipelines, and the demand for real-time responses. This forces a hard choice for backend engineers. Do you stick with Python, the traditional foundation of AI, or do you migrate to Node.js for faster API routing and a simple single-language stack? Can Node.js actually replace Python in a production AI system, or are we looking at the problem from the wrong angle? The Node versus Python debate often overlooks how these two environments occupy completely different layers of the infrastructure. To see why, we have to look at how the nature of the backend has shifted. AI has moved out of the research lab into real-time, production-ready SaaS. This transition changes your backend engineering requirements from the ground up. In a traditional web application, you worry about standard REST endpoints and database queries. AI workloads introduce an entirely different set of constraints. This flowchart contrasts a standard database query on the left with a heavy AI model inference path on the right. The friction points move from the database to model inference latency, GPU utilization limits, and token streaming delays. These specific friction points are what determine your API latency, your infrastructure costs, and your total throughput when users flood the system. Your choice of runtime language directly impacts how well you can manage these specific points of failure. Selecting a tech stack for AI APIs isn't just a matter of syntax. It's a fundamental architectural decision that dictates whether a platform scales gracefully or hits a wall under pressure. Node.js is built on an event-driven, single-threaded, non-blocking I/O loop. This architecture makes Node highly efficient at handling thousands of simultaneous user requests and orchestrating calls to external APIs without locking up. It's particularly effective at streaming partial AI responses back to users via WebSockets or server-sent events, providing that real-time feel. However, as this matrix shows, Node.js has clear boundaries. While it excels at concurrency and streaming, it lacks a native machine learning ecosystem, scientific libraries, and direct GPU integration. Forcing Node.js to act as your machine learning compute engine leads to lacking tools and restricts your ability to run custom models. Python sits on the other side of the fence. It owns the machine learning ecosystem, built on deep integrations with PyTorch, NumPy, and CUDA. It is the environment where models are trained, optimized, and deployed to GPUs. For compute-bound tasks, it is the industry standard for a reason. But Python has trade-offs. The global interpreter lock restricts concurrent operations, creating a bottleneck with a heavy memory footprint. Async Python manages more connections, but doesn't speed up GPU inference. Plus, Python faces longer cold starts and higher memory usage than lightweight Node alternatives. Relying solely on a Python monolith to manage massive concurrent API routing can lead to memory bloat and latency issues when you try to scale. This brings us to the common question: which runtime is faster, Node or Python? In the context of an AI system, that's usually the wrong question to ask. The immovable sources of latency in your system are token generation speed, the size of your model, and the context length. Model inference takes the same amount of time regardless of whether a Node server or a Python server initiated the call. The GPU doesn't care about your backend language. Runtime speed only matters at the orchestration layer, handling back pressure, managing queues, and maintaining user connections while the model processes the request. Optimization at the runtime level won't make your AI smarter or faster. It only makes the system more efficient at moving data around that intelligence. Scaling AI in production often leads to a hybrid system, where Node and Python complement each other rather than compete. This architecture uses Node.js as a scalable API gateway, handling high concurrency requests and real-time streaming. The gateway decouples requests, passing tasks through a message queue like Kafka. Dedicated Python microservices then pull from those queues to execute inference directly on the GPU. This allows you to scale Node horizontally for cheap web traffic, while keeping tight control over your expensive GPU instances in the Python layer. While splitting the stack adds complexity to your observability and deployment, it provides the control necessary to manage enterprise-scale infrastructure costs. Use pure Node.js if you are building an AI wrapper that relies on external APIs, needs high concurrency, and your team is already deep in the JavaScript ecosystem. Stick to pure Python for data science workflows, custom model training, or early-stage research where you aren't yet dealing with massive user traffic. The hybrid stack is for scaling a SaaS that manages its own vector databases, runs custom inference, and processes real-time global traffic. For a production-ready system, separate your API and ML layers early and optimize your architecture for GPU usage, not just raw runtime speed. Node.js does not replace Python for AI APIs. Instead, it serves as the orchestration layer that makes Python's intelligence accessible at scale. The most resilient AI platforms aren't built by picking a winner in a language war. They're built by architecting systems where both Node and Python do exactly what they were designed to do.